And just one more problem. Spider-Man runs and leaps off the ground with initial speed 18 meters per second. He lands at the same height, 25 meters away. At what angle did he jump? We can use our range equation for this. And plug in our values. 25 equals 18 squared sine 2 theta over 9.8. Do algebra. Divide by 18 squared, inverse sine, divided by 2. Gives us a 24.6 degrees. However, thinking back to your knowledge of trig functions that you learned in your pre-calc class, and certainly have not forgotten since then, you might remember that all science teachers are crazy, or all students take calculus, or something like that. The sine function is positive in quadrant 1 and 2. So when I get that the sine of some angle equals 0.756, that there's a quadrant 1 angle and a quadrant 2 angle that solves that expression. So when I take an inverse sine and get 49.12, it also means that the reference angle in quadrant 2 is a solution. And that could also be 130 degrees. And that is equal to 2 theta. I divide by 2. I get or 65.4 degrees. We don't know which one. Okay. What you might notice about these two, or maybe not, but you'll notice it once I say it, is that they add up to 90 degrees. Because of this sine 2 theta, there are always two values that will get you the same range when you have zero launch height, and they are complementary angles, because that's how trig functions work. If you don't remember properties of the sine function and all of that, then I can talk to you and explain why that is in person. But there are always two angles that get you the same distance. So if you fire something at some speed at 30 degrees, and then fire at the same speed at 60 degrees, you'll wind up hitting the same spot if you're starting and ending at the same height. Right? Also based on the sine 2 theta, we know that from the sine function, we know the maximum value of the sine function is 1, and the sine function hits a value of 1 at 90 degrees, or pi over 2 radians. So when is this 90? Well, this is 90 when theta is 45. So we get a maximum range at 45 degrees, neglecting air resistance. With air resistance, it's a little bit lower than 45, maybe like 35 to 40, depending on the object and the air and all that. But any two complementary angles will get you the same range. So keep that in mind. For B and C, I'm just going to use the first of these angles for no particular reason, just so that we have a value to use. What was his maximum height? Well, we can figure this out using the time-independent equation. We know accelerations minus 9.8, max height, that's what we're trying to find. The final y we know is 0. The initial y is 18. Not just 18. Never plug in magnitude into an equation that is in the y direction or the x direction. Never plug a magnitude into anything but the range equation. 18 sine, 24.5, whatever. Always use stored values. And then we can calculate, and I'll get the maximum height that Spider-Man reaches, which is about 2.86 meters. Right? For how long was he in the air? Well, we can just use the time-dependent equation for this. You may have noticed sometimes I'm writing a subscript y, sometimes I'm writing negative g. This is just a more general thing, and and then we're plugging in the value of g. It doesn't really matter which you write initially. Since we're coming back to the same height, delta y is 0. we know the y component of our velocity is 18 sine 24.5 half 9.8 t squared, right? Move this over, you can cancel out a factor of t, because we know that he is at ground height at t equals 0, but we don't care about that solution. So we wind up taking 18 sine of x and dividing by half of 9.8, which is 4.9. We get that time is about 1.53 seconds. So those are our two simple cases of projectile motion. And in class next time, we'll get into the general case. And this is your homework assignment. Have fun.